we're back for another video. This one hopefully is going to be a short one, and it's a gadgety one. I recently found this for a few dollars at my local $2 shop, and I've got a couple of these kicking around. But the reason this was interesting to me is it fits inside a mint tin, and I am looking at making little mint tin survival kits for a bunch of different reasons. Anyway, this has a solar panel on it. But I'm dubious. I've seen lots of these where they just whack a standard lithium cell in here and this little solar panel doesn't actually do anything. So I'm going to pop this open and see what's going on inside. In order to do that, I'm going to grab a pair of pliers here, and I need to open up this little crimp ring, which is here somewhere. We'll give it a little bit of a twist, just enough to remove it. And for the price of this, I'm not too worried if we mess anything up. Now I'll find a spudger tool. Spudger tool to the rescue. Thank you, Tinkerman Mick. I continue to use this endlessly. I need to actually see if he's got any more kicking around. A couple of spares would be handy. Alright, see if we can pop all of this open. I made a broad assumption about how this opens, and I think I was about right. Okay, here is our little setup. Okay, a solar panel is actually soldered onto something, and this looks like a rechargeable lithium battery, but I don't know. We've got, pretty interestingly, we have 3 little white LEDs here, which is good. I've got heaps of them. It's nice and simple. That's how I like it. Although I believe that's one of the contacts of the solar panel, and that is the other. I don't think it's actually connected. I really don't think it is. Interesting. They just used it as a back panel. I wonder if it's actually a functioning solar panel at all. Alright, I'm going to split this off here and see if we can find out what's going on underneath. It feels like a bit of double-sided tape under here. And as I had expected, it's not connected. It's just a little LED torch. And that's a CO216 or 2016. They're non-rechargeable. They're basically that, and the 2032s are used quite often as BIOS batteries. Let's get some wires onto this and see what happens. I'm going to turn on our solder station here. We're going to grab some blue tack, and we're going to grab a little bit of solder, and we're going to see if this panel is actually a functioning solar panel of any kind. Alright, our soldering iron appears to be hot. Time to do something with our solar panel. This is flux core solder, by the way. Makes this job much easier. I do need extraction though. Alright, while we're here, we're going to tin our wires a little bit. Where are we? Going to be in the foreground a bit. I'm sorry if this is a little blurry, and I'm leaning around a camera to do this. So it might not be a strictly perfect shot or a perfect solder join, but we will get there. There we go. Clean that off, and we will solder one onto here. Actually, I'm going to go this way because I want to be able to actually close this up again. So we'll go in here and go in here. Alright. Now I'll go get my voltmeter and see what's going on. Alright, we have my extra cheap little voltmeter here. That is good because it's got a nice LED backlight that we can see. Let me position this better. Alright, we're going to clip on to this, and we're going to clip on to this, and let's see, we've got LED lighting here at the moment, but we've got about 5 volts. So it is actually doing something. I think I need to find an incandescent globe and see what we can get out of it. I'm actually having fun finding an incandescent globe, so yeah, that'll be interesting. I think that in full sun and under load this will probably drop down a little bit, but I think stunningly I managed to get the polarity correct. So let's swap this around and see if I was indeed correct with the polarity. It was about a 50-50 chance. So where are we? This should show a negative voltage now. So that is good. So here we go. I need to make a proper little stand for this meter. So yeah, we're reading back in the positive again. This is under just an LED light strip that's about 1 meter long. So I'm going to mark the polarity on this, and I might hook it up and see if it actually works. And I think I have some supercapacitor somewhere. That might be interesting. You know, I stopped to take a look at this circuit for a minute. I realized something interesting. There's actually not even a current limiting resistor on here. Basically, they're relying on the battery to pretty much provide as much current as it can out of these LEDs, and they've got 3 in series, which gets it over that forward bias voltage. If I put a solar panel on this, I'm going to want a current limit resistor, probably, and I might have to take a bit of a stab in the dark, but I'm going to do a quick little bit of maths and see what I've got and if it'll work. Alright, so I've done a quick little check here in the process of doing my maths. I've stuck a 390 ohm resistor across this panel, and I've chucked my voltmeter on it. I want to find out what the voltage is under load. 390 ohm is about what I would normally put on an LED. And at 390 ohm, we've really got nothing coming through here. So I guess my load is going to have to come down, or the amount of light that I push into this panel is going to have to come up. So we're producing less than 30 milliamps, so I'll say that much, because that's about the load with a 390, or at least at 30 milliamps is a 390 ohm at about 12 volts. Off memory, my memory may be wrong. So at 5 volts, that's actually going to go up quite a bit. So we're probably trying to pull about 100 milliamps out of this, which we've got no hope. All right, let's see what else we can do here. Now, in the absence of an incandescent globe, I've got a very, very bright LED globe here. And so we're going to push under load. We're not going to go sky high voltage wise. We're probably going to push about 3 volts, which is about what we would expect to charge it. The amount of current, I think, on this, I probably won't need a current limiting resistor. I think this is probably going to be just enough to do the job on that. I think originally they were probably designed to do this. So anyway, let's hook it up and see what happens. Alright, so I changed the way the cable was routed slightly, and that allows the button to actually function, albeit a tiny bit spongier than it used to be. And this hopefully should, for the large part, go back together. It doesn't click like it used to, but it still functions. I can push the button, and I guess we'll see how long it lasts. I won't really know, but we'll see if it blows up. I will comment. I'll leave this in the sun and see what happens for a while, but it'll probably get warm, I assume. And hopefully by the time this video goes live, I'll have some idea of if this is a good idea or not. Alright, see you in the next one, and have a look in the comments to find out how it went. So a quick little addendum to this. I thought I would open it back up again and fit a bleed back diode. And in the process, I ripped the contact off the solar panel. I don't know if I'll get it back on there, but I might just go buy myself another one of these and modify it again. But either way, the lesson is still learnt that most of these things, the solar panel is doing nothing. And to be honest, this will give you quite a decent amount of lifetime of light from it. And you can easily swap these batteries over if you really want. But basically, it's a good way of selling batteries. Alright, we'll see you in the next one, and hopefully it'll be a bit more successful.